Thank you. All right. Hi, everyone. Really happy to be here in Hungary, Budapest, my first time. Really attractive city here. It's kind of cool that the previous guy's name was Attila, right? It's kind of, really apt for this place. But anyway, let's get started. So my name's Max Millington. I'm an engineering manager at OsmosisLabs, which runs the Osmosis Decentralized Exchange and blockchain. If anyone wants to talk about that, we could talk about it in the hall or in the break room. I'm not going to go into that now. But today, I want to talk a little bit about my background and how it's influenced the way I've approached, I approach software engineering, and with the goal of, I want everyone to kind of, obviously I'm going to talk about philosophy because that's my background, but I want everyone to take something from your own non-tech backgrounds and apply that to the technical world. So as someone who's been in the industry a while, I've been on plenty of interviews, plenty of network calls, plenty of resumes sent out, and the first thing people notice is that my educational background, my life before entering the tech industry, I've been in the tech industry around 10 years, really doesn't have anything to do with engineering at all, per se. So I think the industry in general does a pretty good job of not gatekeeping. It allows people to get into the field so long as you could demonstrate competency, the ability to do your job. Nevertheless, this is a really regular topic of conversation with me, and I regularly experience a lot of kind of surprise that someone who came from like a liberal arts background is in a technical field. So anyway, it makes me it forces me to think, okay, actually, how has philosophy influenced the way that I approach software? And the truth is, in many ways, but I'm going to talk about a specific way today. So as I mentioned, my background's in philosophy, specifically ancient philosophy, and so ancient Greeks, Romans, things like that. Plan A was to work in academia and do the whole professorial thing. For a variety of reasons, I determined that was a bad idea, which also we can talk about in the hallway if you want. I've got a whole host of opinions on that. But TLDR eventually landed in the tech industry as a software engineer. And like I said, when I interview, I remember my very first interview, people would say, oh, like, how did you get into this? And I think they kind of expect me to say, like, oh, philosophy didn't have anything to do with it, but I was always like super, into computers or something like that. And I think that in truth, like I said, there's quite a lot of applicability on a day-to-day basis from philosophy. Not only from philosophy, but also like a lot of the ancillary studies that support philosophy. So having specialized in ancient Greek and Roman philosophy, I learned ancient Greek and classical Latin. So for example, when I was a junior engineer, I remember my very first product meeting 10 years ago, and my product manager said something like, oh, we're going to iterate on the product. And I'd never heard the word iterate before, but I knew what it meant because I knew the Latin word iterare, so, which is the etymology, which means to do something again and again. I didn't know what isomorphic meant, but I know what isomorphos means, which is also Greek. I didn't know what heuristic meant, but I know what herisko means, which is ancient Greek. So you get the idea. So, but anyway, that's a little bit of a little irrelevant. So naturally, the whole claim of philosophy is that it's kind of a first science, namely that it's applicable to every posterior field of study. That's a little bit too theoretical for this talk. That's like kind of a paper-long topic, not a 30-minute long topic. Because I could give a whole host of reasons of why software engineering architecture, GPUs, CPUs, all ultimately stem from various principles that you learn from philosophy. But again, maybe we could talk about that, during the after party over beers or something like that. So instead, I'm going to talk about a specific philosophical theory, as was mentioned before, and how to go about thinking about real-world applications. And again, I'm going to talk about philosophy, and I want you to learn something about this philosophical theory and its critiques. But I think the upshot from this talk is I want you to take away something from your own non-technical life and think about it differently in your day-to-day tech life. So for example, if Tejas and I were talking about cars, yesterday, and let's say you're really into cars and driving cars is your hobby. If you know a lot about cars, you know if you want to make it faster, you could make the engine bigger, but you could also make it a lot lighter. And that sounds an awful lot like writing JavaScript in the modern ecosystem to me. So anyway, let's talk about Plato's theory of the forms, as alluded to before. So if you've taken a history of philosophy course or an introduction to philosophy course in college, there's a pretty good chance you've encountered this. It's one of the most influential ideas or one of the most influential theories in Western thought, called the theory of the form. Sometimes it's called the theory of ideas, if you've heard that. That's the Greek word that sometimes Plato would use. So it's essentially Plato's attempt to explain how knowledge of universals is possible. Now, the ancient Greek thinkers, they spent a lot of time ruminating how to answer the question, what is it? So if you ask, what is X? What is Y? What is Z? Sounds like a trivial question, but it's actually not. It's not only is it hard to give a universal account of an individual thing and what it is, but it's also hard. The ancient Greeks also noticed that it's also even harder to know how it's even possible to go about knowing what a thing is. So, we talked about circles. I know all of you here are human beings. That presupposes that I know what a human being is. I have some notion of a human being. And I also know that that even though you are all human beings, you are not human being, because otherwise you'd all be the same thing, but you're not all the same thing. You're many people that are the same type of thing. So what it is to be a human is a universal thing that persists between the individuals. And then when an individual human passes away, what it is to be a human doesn't. That remains. But if that's so, how do we know what the universal thing is when all we have access to is these temporary material instances that are passing, that are coming and going? Similarly, how do we know that human being is even a universal thing? So the ancient Greeks had many schools of thought, including some ideas that were pretty radical. Some thought that we didn't know anything at all because everything's passing away and coming to be. Others thought that nothing even exists at all because everything's passing away and coming to be. But most of the authors of these theories, for understandable reasons, they didn't become household names like Plato. This is in part because Plato was famously one of the most eloquent speakers in all of written history, at least in Western written history. But it's also in part due to the influence of his solution, I think the intelligibility of his solution, and the influence throughout Western history. So let's go a little bit of detail into the theory itself. So Plato held that the form of the thing, which again sometimes translated as the idea or look of the thing, is what's actually known. So you don't know the individual material because the material is passing and going, but what you know is the form of the thing. So if I see something that is triangular, what I know about it is the form of triangle, rectilinear line, plane figure contained by 3 rectilinear lines, rather than the incidental attributes, which would be its color, its size, etc. Those things pass away with the thing itself and per se aren't knowable. Because what it is to be a triangle is unchanging, otherwise you couldn't say that each triangular thing is a triangle. Plato thought that there was a separate world where forms actually existed, whereas the here and now of the physical world is merely a shadow or a reflection of the true reality. The world as perceived by the senses is, as I mentioned, changing, decaying, fundamentally imperfect, while the realm of the forms is where truth, which is by definition perfect and unchanging, can be attained. So we mentioned a circle again. Let's think about the circle. Presumably you've never seen a perfect circle, because anything circular, you zoom in far enough, there's ultimately some sort of angular imperfection, or there's a planeness of the containing line. It's not perfectly curved. The Earth is like this. The Earth isn't a perfect sphere or a perfect, not circular. But everyone can know what a circle is, the true form of a circle, the definition of which is a plane figure contained by one line, such that all the straight lines falling upon it from a point among those lying within the figure are equal to one another. Basically saying that all the radii are equal. But Plato applied this theory to all disciplines, including practical disciplines like ethics. So he thought there was a perfect form of justice or a perfect form of courage in which individual acts of courage or justice imperfectly participate. So Plato still had an issue about, how do we go about accessing these forms if all if all we know is like this world, this physical world now. The point of this talk isn't to go too deep into Plato, but he ultimately ends up thinking that the human soul itself is immortal and subsists in the realm of the forms and then are reincarnated in various human beings. And when you come to know something, you're actually just remembering what you knew in your previous life in the form world as the forms exist in the heavenly realm, so to speak. This is why if you've ever read the Apology by Plato, which is where the account of Socrates' condemnation and execution, obviously everyone's sad that Socrates is going to be executed, but he's like a little excited because he's like, he's a famously knowledge-seeking Athenian, and he's saying, finally, I'm going to be free of, my material body and get to the place where knowing actually happens, and I can actually know stuff in the form world. So the impact of Plato's theory on Western thought has been pretty profound. Later Christians, Muslims, and rabbinic Jews all were heavily influenced by Plato. They applied it to the whole host of domains, and I would wager that, as I mentioned above, I would wager that if you took a philosophy class in college, you've probably heard of this theory. It's very famous. Moreover, I would even wager that like a large proportion of contemporary mathematicians are either functionally or explicitly Platonists. I don't know if anyone has a math degree or something had a math degree in college, but if this came up, chances are most of the mathematicians you met were explicit Platonists. So now let's talk about our own field a little bit. I see a lot of unintentional influence here. I don't think anyone proposing a new framework, model, pattern, library is explicitly a Platonist, but I do see a lot of kind of pseudo-philosophical, pseudo-universal language at conferences, documentation, blog posts, etc. Or at the very least, I see this kind of universalist attitude that was common among Plato, common in software engineering as well, and it's reminiscent of the perfection that Plato thought that he was achieving with his knowledge. If you've been in the industry a while, you've likely seen numerous trends come and go, all of which have the claim to be the one true perfect way of building software, one perfect way of writing tests, the perfect way of organizing your code, etc. If you've ever read like JavaScript, the good parts, it's basically, here's the big JavaScript book, and then JavaScript, the good parts is based on the functional paradigm. You rip all that stuff, so all that's left is the functional, which is the true, good, pure JavaScript. Everything else is, a pollution of JavaScript. Fair enough. If you think about your own career, like who spent months migrating code bases to GraphQL when GraphQL was like the popular thing that you must do? It was the promise that this single endpoint with a declarative style provided the most elegant flexibility and efficiency. This strong typing, schema definitions, self-documentation, bug squashing, it's all kind of built in. It's the fastest way to get your data. It's got paradigmatic caching, versioning and overfetching were a thing of the past. Everyone had to switch to GraphQL, right? I remember I used to work at a large company, and we had this entire infrastructure based on REST and status codes, and then we were like, but REST is ugly. It's we need to use GraphQL, and we switched to GraphQL, and none of that infrastructure worked for us. Who here works at a startup and has had with a small CRUD app with X number of users and decided to build microservices or micro front ends? Separate your concerns. Each team freely able to foster software innovation and diversification. Sorry, I realized I forgot to shut off my notifications. I'm getting notifications. But it was like this micro front ends, microservices, they were the perfect form of modularity and self-ownership. And maybe a little bit more controversial example, who here is old enough to remember writing tests with Enzyme, and we junked it all for React testing library? And it was because we had this kind of perfect principle of unit tests should match the real-world experience of users. Granularity and CSS selectors were all replaced with deep mounting and finding text. I could go on, but we switched to this or that framework or even rewrite beloved libraries from scratch, all for the sake of being more functional, more solid, more declarative, et cetera. Or even if we don't think about engineering, if you think about like Scrum, who here has been on a team where it's like Scrum is the one perfect way of building software, you have a Scrum master who has a degree in it, and you have to follow these meetings to a T just because it's the best way to build software. So you get the idea. So I want to talk a little bit about Aristotle, who was a pupil of Plato and kind of developed, influenced by him, but developed a different methodology, which I want to share. So it's out of the scope of the talk to discuss the metaphysical epistemological objections Aristotle raised to Plato, but in general, I want to say it's fair to say that Aristotle took a much more practical, down-to-earth approach to philosophy. And this is the school of Athens, and Plato's in the middle with his finger pointing up towards the world of the forms. Aristotle's got his 5 fingers pointed down to the earth, which represent the 5 senses. The idea is that actually no truth is here, that you can learn about it from your 5 senses. So Aristotle argued that there were not perfect forms subsisting on their own in some special realm, but rather the forms exist here on earth as essential components of natural objects. So justice as a form only exists in just actions performed by us. Circles exist as the form of a material object. Water exists here in the sensible world. You have hydrogen and oxygen as matter, and the ratio between the two is the form. And the objections Plato raised about imperfection of the material world, Aristotle solves by arguing that the idealized versions of these things, the definition of a circle, justice, triangle, etc., these are abstractions that we make, and these exist in our minds. But they exist in, but the real existence of the things is in the material world. So, what might be the upshot and implications of the response? So let's think about an example like courage. Aristotle thought the idealized form of courage was the mean with respect to fear and confidence, and he thought that the most paradigmatic example was battlefield courage. But does this mean that other courageous acts aren't courageous? Of course not. Just because something isn't a paradigm doesn't mean it isn't an instance of the thing. Perhaps asking for a raise isn't as courageous as courage on the battlefield, but it's courage nonetheless. And I think, indeed, sometimes it takes more courage not to go to battle than it does to go to battle. The point is what we do in each situation is a matter of prudential judgment. And it's appeal to prudential judgment that I think is lacking in the constant barrage of new programming paradigms, libraries, and frameworks. I mentioned functional programming as a subset of JavaScript, and I'm not here to tell you that that's a bad paradigm. I think that that's a great paradigm. But I am here to tell you that I've been in repos written by the people who wrote JavaScript, the good part, and I've seen the way that code looks. And writing the entire repository that way, based on that idealized form of programming, such that anything that falls away from the paradigm, I think that should be avoided. And I'll talk a little bit about why. So let's not forget about why we're doing what we're doing. Are we software engineers because we think code elegance is a virtue per se, or that modular code is something good for its own sake, or is like the beauty of microservices a well-architected micro front end? Is that a suitable life goal? I mean, I don't think so. In reality, I think that the principle behind what we do, why we do what we do, is we're trying to make users happy. Do my users care if I use React or Vue? No. Do they care about performance of my app and the speed at which I release features? Yes. So I think if we run our organizations such that our fundamental principle is that we want to build experiences that make user happy, again, a more prudential, practical goal. After all, that's how we make money, right? By making users happy. I think we end up with a developer experience and a user experience that is quite different than one that is instead run by more idealistic engineering principles. I've got a couple examples here. So remember Redux sagas? Like if anyone was old enough to remember Redux sagas, when it came out, I remember thinking that it was like the coolest library, the pinnacle of the Redux toolkit. Use fancy solutions like generators to handle asynchronicity in JavaScript. It felt like I was like the hippest JavaScript developer writing Redux sagas. But these days I wouldn't dream of using it. And it's not because it's not a great library. I think it is a great library. But because especially as a manager, I have to worry about things like hiring, onboarding, ramp-up costs, developer interests. Let's say my product has a huge influx in users. I need to scale up the team super quick in order to ship new features fast. I love hiring super experienced engineers with a lot of domain-specific knowledge, but that's not something that you can do all the time. Maybe you need to hire a bunch of junior engineers or a bunch of senior engineers that just have no experience with your stack. they need to onboard and learn quickly. So do I really think I'm going to have an easy time doing that with Redux sagas? And I think the answer is no. So I want to make my users happy, which means shipping things fast. So maybe the library I use isn't as cool, isn't as perfect as something like Redux Saga, but that's okay with me because I'd rather use a simpler solution that'll enable us to get things out the door. I added this last night when I was discussing this with someone in the back, where I used to be a Ruby developer, and I really love Ruby. It's one of my favorite programming languages because it's explicitly written to feel like you're reading English, so you feel more like a human reading it than you do a computer. And that's really great because it's like low IQ programming. I like low IQ programming where you could hire anyone, they could read and they could see what it is. But the Ruby community, in my opinion, suffered by a lot of experienced engineers who are trying to do things just a little bit more elegant, a little bit faster. And now if you read a Ruby app, it could be there's all this like weird esoteric symbology that is very far removed from like the original goal of let's just make it read like English. So even if we think about our beloved React framework, remember the early days of React when we had maybe not the super early days, but remember when we had class-based inheritance? At the time, I thought that, that was a real pain point and low point in React because after all, classes are just syntactic sugar in JavaScript. A more elegant and correct way would be to have a more functional style in the framework. Well, I got my wish, and I think everyone else got their wish with hooks. And I ask you now, however many years it's been, are hooks really easier? Is your life really easier because of hooks? Sure, we pursued a more functional model, which again, I agree is the best paradigm in JavaScript. But in my experience, hooks are not only less intuitive, they have a higher learning curve, but the ecosystem is rife with these not even that large of applications. They're in kind of a hook hell. You'll go into an app and you'll have like 30 import, use, whatever, and it's very hard to know where your logic or your data is coming from. And then I ask you again, do my users care about this functional paradigm? I think the answer is no. But what they will care about is when I can barely read a new code base and it takes me a long time to ship a new feature. Again, I've seen these paradigms come and go. And then, the question is, I think we need to come back to which one is actually going to be the most practical for you and your team. What's the upshot? In wrapping up, I want to say it's essential to remember, that the pursuit of idealized forms in software engineering, software development, can inspire us to strive for excellence. I'm not saying we shouldn't do that, but I think it's equally important to stay grounded in practical realities. Who's your team? What's your timeline? How much money do you have to spend on X, Y, and Z? And I think that as you've probably seen in your careers, an overly rigid adherence to theoretical ideals, whether in the form of functional programming, microservices, other paradigms, what have you, these can lead to complexities and challenges that ultimately detract from our primary goal, delivering value to our users. By embracing, I think, a more balanced approach that values pragmatism, prudence, alongside idealism, we can create more effective, maintainable, and user-focused solutions. So again, I look to, this is one philosophical insight that I've looked to help me inform my technical decision. But I want think about your own non-technical experiences and how you can apply that to your technical life. But always keep an eye towards the practical needs of the project and the satisfaction of your users. Anyway, thank you.
Thank you.